Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video we're going to learn about data classes in Python, so let us get right into it. Alright, so we're going to talk about data classes in Python today, a concept and a feature that was introduced with Python 3.7. It's not the newest feature, but it's very useful and very interesting. Nowadays, whenever we implement data-based or data-focused classes, we want to use data classes. That's the best practice and the modern way to do things, the go-to way to do things. And data-based, data-focused basically means we have a class that is mainly there to structure and store information or store information in a structured way for us. For example, what would be a data class or a data-based class? A data-focused class would be something like car, where we basically just have manufacturer and model name or whatever. Or another data class would be person, where we have name, age, weight, height, gender, whatever. Another one would be computer, where we have some information about the computer. So these are all classes that are used to store certain fields. So we have a field name, age, weight, height, and we want to have this class to store these informations, to represent them, to be able to compare them and all that. That is the goal of data-based or data-focused classes. In contrast to that, we also have more functionality-based, functionality-focused classes. For example, classifiers. If you use scikit-learn, you have regression objects that are based from a regression class, or that are an instance of a linear regression class, for example, or a classifier class. Or in the hashing module, you have hashing classes, and you have in the XML module, you have parsers and all that. These are all classes and objects that are used for their functionality. We don't use them to store name, age, height, whatever. We use them to call functions to do certain things and to get certain results. And whenever we use data-based classes, we can use data classes to make everything more effective, more efficient, more professional, and less prone to errors. So let me show you an example right away. Let's say we have a class called investor here, and we're not going to use data classes first. Now, if I want to have an investor, I want to have an investor that has name, age, and a cache level in a web app, for example. Let's say this is a big application, and I want to create this investor class, and I want to have in a database also an investor table and all that, and I want to map everything later on and so on. And what I want to do now is I want to have this investor with name, age, and I want to have a cash amount that this investor has ready to invest into assets and securities. So what I can do is I can just create a simple constructor here, self, name, age, and cash. I can also, to make it more professional, provide type hinting here. So integer and float, for example. And then I say self.name equals name. Self.age equals age. Self.float equals float. Like that. Self.float is not right. Self.cache equals cache. Sorry. I was brain AFK. There you go. So this is a basic constructor. Now, what can I do with this investor class? Let's go ahead and create an investor 1. I1 is going to be investor. We're going to call this guy John. John is going to be 25 years old, and he's going to have like $9,000 in cash. Now let's go ahead and create 2 more investors. Let's say I3, I2. And now I have, I don't know, Anna. Anna is 30 and has like, I don't know, $12,000. And then we have Bob, and Bob is like 70 and he has like $800,000 ready to invest. Now, what can we do with these objects by default? Of course, we have the constructor because we have created the constructor. This is why we can even call the constructor here. But besides that, what happens if I print I1? What happens if I do that? Let's go ahead, run this. We're going to see main investor object at a certain memory address. So we don't really get any information. We don't get a representation. And those of you who know the basic double under methods that we have here, you know that we can change that by just implementing the representation method here. So we can say represent, and then I can say, okay, return, I don't know, name is self.name and whatever, and I can do all that. Let's just say we want to have the name. We don't want to have age or anything else. We want to only print the name. By doing that, we get this as a result now. So I have to manually implement the representation. Now, what happens if I want to know if For example, let's create a fourth one. Let's say I4 is investor, and it's going to have the same fields. It's going to be John as well. It's going to be 25 years old and also 9,000 in cash. And now I want to print I1 equals to I4. Is that true or not? Are they the same or not? It says false. Okay. So basically it will only say true if I say I1 equals I1. It's not gonna say, okay, those are the same fields, so they're equal, because we don't have an implementation of the equal method. So I could go ahead and say, okay, underscore underscore eq self other. Then I can say, okay, return self.name equals name. So this, of course, dot other name, sorry. This, of course, would mean that two investors are equal when they have the same name. Doesn't make a lot of sense in this case, but in this case, even if I change the age here to 50 and I change this to $100 and then I compare I1 with I4, then I would get true because we have manipulated the equation method, the equals method. And of course, we can do all that professional. We can say, okay, if all the fields are the same, we can decide what we want to do. But the fact is that there's no default functionality. So if I say, for example, I1 being less than I4, and by that I want to say, okay, does this investor have less cash than this investor? It's going to give me an error message because the type is not supported. So what I could do is I could go ahead and say, okay, less than implementation self other, and then I could go ahead and say, okay, return if self.cash is less than other.cash. And I could run that, and we would get false because that's not the case. Now, what happens if I turn this around and I say greater than? Oh, sorry, I opened the settings. Greater than, it says true. Okay, so you can see that we can do all that, but we have to do it manually. And the problem is that if I now change something, and this is just the beginning, right? We can do a lot of more things. We can do stuff like hashing and stuff like very many other methods that we can use here. But in the end, if I change something here, so let's say I want to also add a list of assets, or I want to have, I don't know, a birthday or anything, any additional field that I want to add here, I would have to go through all the functions that I already have here, all these less than, equals, hashing, representation, all the different functions, and I would have to change everything, and if I forget something, it is prone to errors and all that. So this is not the best practice way to do it nowadays. And we're going to use data classes to make this more professional and less prone to errors. So we're now going to implement the same investor class, but this time using the best practice way of data classes. And for this, we're going to start by saying from data classes, import data class. And data class is basically just an annotation, a decorator we can add to a class to make it a data class. So let's say we have class investor again. We have a placeholder pass. And up here, I can now add @data class, and this makes it a data class. What does that mean now? It basically means that I don't have to provide a constructor. I don't have to provide an equals method. I don't have to provide a representation method. It's all going to be done for me. It's all going to be done for us. All we need to do here is we need to provide the fields. So for example, the investor has a name, and the name is a string. So name colon string has an age, integer, and cash, float, like that. That is the investor class. Now it's a data class, and as you can see, there's no constructor, there's no representation method, there's no equals or anything, but I can still go ahead and say I1 equals investor, and the investor is John. John is now 80, and John has $700 on his account, and I can go ahead and say print I1. And when I run this here by pressing run main, you can see that I get a nice representation here, and I can use this constructor even though I have not defined it. Now, if I remove this data class here, it's not going to work anymore. It says unexpected argument. If I run this, you can see it takes no arguments. So we need to use the data class annotation here to make this possible. Now, also, if I add a second one here, I2 equals investor, and then I have like Mike, and Mike is 18, and Mike has like, I don't know, $2,000 on his account. And if I now say I1 equals I2, it's gonna say no, false. But if I have a third one, for example, and I say this is also John, and John is also 80, and John has also $700 on his account, And if I now say if I1 is the same as I3, it says true, even though this was not the case if I were not using a data class, because then it would only return true if it's the same object. So this is also already implemented for us. And the good thing is, again, if I want to add a field, if I want to add a new field here, for example, I don't know, favorite sport for some reason, and this is a string, everything is done for me. So I can, of course, add a new field here, and I can say soccer, and I can say baseball, and I can say basketball, whatever. I now have the same behavior here. So I have the comparisons, I have the printing, I have the constructor fields. I only need to add one line to make all this possible. I don't have to go through all the functions with a chance of missing something and making an error. I can just add this new field and everything is done for me. Now, what if, for example, I want to add a field, but I don't want to represent it? First of all, what you can always do is you can just go ahead and override the representation function. Just because it's done for you doesn't mean that you cannot override it. So if I say, for example, repr self, and then I return hello here, it doesn't matter what the data class does. I can still go ahead and just print I1. Let me just remove the soccer here, and the basketball, and the baseball, and the basketball. There you go. If I now run this, you can see hello, because that is the representation function that is called. So I can still override it, but there's of course a better way to do this. So all we do here is we manipulate the individual fields. And in order to do that, we need to import something called field. This is a function that we can use. And if I want to set certain things for a field, I can just go ahead and say, for example, for cache, if I don't want to print the cache whenever I print a full object, I can just go ahead and say equals field and then repr equals false. This means that when I call the representation function, cache will not be included. So if I run this now, you can see name John age 80, but no cache there. I can do the same thing, by the way, with the comparison. So I can say, okay, when we compare two objects, don't care about the cache. So compare equals false, for example. And if I do that now, and we have John and John, both are 80 years old, but they have different cache levels. So $700 and $900, then I1 and I3 is going to be the same, even though they have different cache levels. But if I don't add compare equals false, by default it's true, then it's false because the cache is different. So I can include and exclude fields as I want. I can do the same thing, by the way, with init. So I can say init equals false, and then I don't have to specify, or I can't even specify the cache in the constructor. So I can set all sorts of things here in the field function here to make the behavior of the data class change. And of course, by the way, I can also just set a default value. So I can say default cache is going to be 0. So I can, actually, let's do it without spaces. I can say, okay, or let's do it 0.0. I can say, okay, I can provide a cache level if I want to. Let's go ahead and set this to true and print I1. I can set a cache level and it's going to be printed, but if I choose to not provide a cache level, it's just going to go with 0 as a default value. Whereas if I don't provide that keyword here, it's going to say that I'm missing a parameter here. So if I run this, you will see that missing one required argument. So we can manipulate these fields like that. Now let's go ahead and make our data class even more powerful by adding the order keyword. Because right now, if I go ahead and say print I1 is greater than I3, I'm not going to be able to do that because this is not supported for this class. So I can run this type error not supported for instances of investor and investor. So what we can do to change that is we can just go ahead and say order equals true in the data class decorator. And when I now run this, we're going to get some result at least. So I1 being larger or greater than I3. There you go. You can see it's false in this case. But this result is not exactly what we want because it just takes the default way of comparing objects. What we want to have is, in this particular case, we want to compare the cache only. So we want to say, okay, I1 is greater than I3 if I1 has more cache than I3. and vice versa. Same goes for less than, obviously. So what we want to do here is we want to have a custom way of sorting, a custom order. And in order to do that, we need to add a so-called sort index. So I need to go ahead here and say sort index is going to be a float, and it's going to be a field that won't be initialized because we don't want to set it manually. So init false. And we also don't want to represent it. It's just something that works behind the scenes. And this sort index is what's going to determine the order of the object. So this is what's going to be used for sorting primarily. And in order to set it, what we're going to do is we're going to set it after the initialization process. So after we have the values for cache, age, name, and so on, we're going to set it to the cache value. So we're going to call the post init function. We're going to use the post init function to say, once the initialization is done and I have a value for cache, say self.sortIndex equals self.cache, like that. And now we can go ahead and see what happens if I say print I1 is less than I2. And if I run this now, not debug, come on, terminate. If I run this now, you will see true because 900 is less than 2000. If I change this to 2001, this is false. If I change this to 1999, it's true again. Now, the only thing is that if I change this to 2000, oftentimes it's going to say true. This is because the equal function is a little bit different here. But for basic stuff, you can see that this works. And this also works when it comes to sorting a list of investors. So if I have a bunch of investors here, let's say we have Mike, John, Anna, and Anna has like 1,000, Mike has 4,000, then add a couple more here, 4 and 5, and we have Bob, and we have, I don't know, Charles, there you go, 70 years old and 18 years old, and here we have 800,000, and here we have $100, or actually let's go with $3,000. So we have these investors here, and we can say we have a list. My list is going to be I1, I2, I3, I4, I5. This is the basic list in that order, and now I want to sort this list. So let's print, or let's say my list.sort, and then print my list. If I do that, you're going to see that they are sorted by cache levels because that's the default comparison method, as you can see. So we didn't have to do anything. We have to specify the sort index. So basically say, okay, what is the sort index? We want to sort by cache. But besides that, we didn't have to implement any functions like the constructor, the ordering, the comparing, the representation. Everything is done for us. And this is also the case for hashing. If I want to be able to hash the investor class by default, I can either make this a frozen class. So I can either say frozen equals true, and this would make the class immutable and also add a hash function, or I can also say unsafe hash equals true, which makes the class mutable but also has a hash function. So this is of course insecure because hashing doesn't make a lot of sense if we have mutable objects, or at least it's unsafe. But by doing that, I can just go ahead then and print hash of I1 and hash of I2. And the good thing is that we're going to get the same hash for the same object. So if I have, let's say this is now I9 for whatever reason. So we have I1 and I9 have the exact same values. If I hash both of them, we're going to see that they have the same hash value, as you can see here. Now, if I change something, for example, the balance here to 200 instead of 2000, they're going to have a different hash. However, I can go to the field, which is the cache, and I can say hash equals false. But you're going to see that the hash is going to still be different. And the reason for that is because the sort index is the cache. So we need to say hash equals false here. And then we're going to ignore these two fields for hashing, and we're going to produce the same hash, as you can see. So that's it for today's video. Hope you enjoyed. I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.